Hi, hello everybody. Welcome to a new Polkadot deep dive session. Today we are going to be talking about Asset Hub. I'll start with an introduction about what Asset Hub is. Then I will follow with high-level features. And in the end, my colleague Emiliano will do a demo about how to use foreign assets and a quick code walkthrough. Before we start, we recommend you to have at least like a basic knowledge about concepts such as XCM, multi-locations, derivative assets, sovereign accounts, etc. So if you don't know about it, here you have the QR codes that will bring you to previous deep dive sessions, especially about XCM. Okay, so Asset Hub. There are two Asset Hub, production live. Asset Hub Polkadot and Asset Hub Kusama, and then there are another two in the test networks for Rococo and Western. It was the first of his kind. It's a system parachain. And what are system parachains? System parachains contain core Polkadot features. In this case, it's asset deployment and management. The goal is to remove these core features from the relay chain to have more block space for parachain validation, or what's called in Polkadot 2.0 core time. Another main characteristic about system parachain is that they are trustable entities. This is because they are secure by the Polkadot and its governance. Sorry, so thanks to XCM, it's possible to move these assets around. It's not only about creating them and manage them. You can move them with through two ways, teleports. It needs like a high level of trust, usually is bidirectional, and reserve transfers with a low level of trust, and the trust it's only one way. Here we have a great diagram made by my colleague Emiliano, where it explains how asset teleport works. So we have two parachains. So if we want to teleport assets between these two parachains, in the origin, the assets will be burned. And then you have to trust that the destination in the parachain B, they will be minted. Alternatively, we have reserve asset transfer, where the system parachains plays like a very important role. This is the trustable third-party entity. Here we have parachain A, the reserve, the system parachain, and parachain B. So one of the most complex reserve transfer is from parachain A from parachain B. So in this case, parachain A would have to burn those tokens. Then here is where the trustable part happens. So instead of burning and minting same token in parachain A and parachain B, what happened is the tokens are burned in the sovereign account of parachain A and are minted in the sovereign account of parachain B. When parachain B detects that those assets have been minted in the reserve, they can mint the assets in their side. And here an example of about what's happening right now. We have like a teleport open between Asset Hub and Polkadot, basically because they trust each other because they are part of the same consensus and governance. And you have reserve transfers between, for example, Moonbeam and Astar through Asset Hub. Let's talk about the high-level features. First of all, we have NFTs. It's formed by 3 pallets, Unix pallets. It's deprecated in favor of pallets NFTs. It's planned to ask users to migrate their data via UI. It's still like work in progress. Then the new pallets NFT, where you can create collections, mint and burn items inside those collections, lock and lock collection items, atomic swaps. Basically, it's like an end-to-end exchange of tokens without the need of a marketplace, for example, any kind of intermediary. We have set price and buy, which allows marketplaces, and smart attributes, which are a kind of evolution of metadata, where you can allow certain origins to modify that metadata. So for example, you could have NFT, which is a badge, and one of the fields can be modified, for example, coming from collectives, saying, okay, you have this badge and your rank is going to it's going to change from rank 1 to rank 2 or vice versa. And finally, pallet NFT fractionalization, which allows to lock an NFT, create and mint a new fungible asset. This is, for example, for security assets. If you have, let's say, a building, you can create an NFT that represents a building, and then you can create participations like shares of this building. So everybody becomes like a small owner of this NFT. I will not get very deep into the palette because we have already like a deep dive talking about this. Please check it out. Next feature, local assets. It was the first pallet asset instance in Asset Hub, where anybody can claim an asset ID. There you can mint a barn assets. You can see the total instance in the entire Polkadot system, and you can set the metadata. There is like a warning sign there because this is very important to understand, because any sign origin can create assets with arbitrary asset IDs. Then someone could try to create like a fake, for example, USDT, USDC. So users need to diligence to make sure that the asset that they really want to transfer is the legit one. So right now, Asset Hub is home of these two reserve-backed stablecoins, USDT with ID 1984 and USDC with ID 1337. Here we have an example of the pallet configuration. And two things to focus on. It's the asset ID, as I said. It's integer and sign integer, and then they create origin, any sign account. Again, we'll not get very deep into this because we have also like a deep dive about assets pallet. Now, foreign assets. What's foreign assets? So it's the second instance of the pallet assets. One of the differences, assets are managed by some foreign location. This foreign location should be always the only one that is accepted is a sibling parachain. You can see there the multi-location. It's basically parents 1, interior x1, parachain with a parachain ID. And the asset ID is a multi-location instead of a sign integer. Why? Why do we need another instance of the pallet assets? First of all, because multi-locations are way more expressive than unsigned integers and even contract address. And at a glance, you can see and understand the nature and the owner of an asset. Here we have 3 examples. The first one is other parachain native asset. It would be from the point of view of Asset Hub. Parents 1 means to go 1 level up. That's the relay chain. Then go inside the interior parachain. If there is no more information, it's supposed to be the native asset. Next example, other parachain local asset. Here, the difference, as you can see there, is you have the pallet instance 50, which in case of Asset Hub is the local assets palette, and then general index that represents the asset ID. And finally, you could even like represent like breached assets. Here you have parents 2, which means I go to the relay chain, and on top of the relay chain, you have this kind of like a universe with different global consensus. You can like jump to another global consensus, for example, Kusama. So that would represent the native asset of Kusama. Second reason, it's a single entry point for wallets, custodians, and exchanges. It simplifies asset management and simplifies integration. Before, integration of parachain tokens requires running individual parachain structure like full nodes and potentially additional code to handle withdrawals on each individual parachain. With foreign assets, you can just monitor one chain, Asset Hub, for deposits. And for withdrawals, users could choose to do it to do their address. Sorry, users could choose to do it to their address on Asset Hub with asset transfer, or to their address on their parachain through XCM reserve transfer asset. Asset conversion. This is the newest feature. It's basically a simple automated market maker based on Uniswap version 2 logic. The main goal is to enable fee payment in any asset, such as the fee handler, in this case, collators only receive the native asset, dots. Improve the optimal previous version we had, that it was based on the ratio between the mean balances of sufficient assets, and the conversion rate comes from the liquidity pool. There are 3 building blocks that are 3 pallets in the Asset Hub runtime. The first one is pallet assets conversion to extension payment, where a signed section is implemented to handle the fees. Then the second one is the pallet asset conversion, where the AMM is implemented. And finally, pallet assets. It's the third pallet asset instance, where the liquidity tokens are created. Let's see how these 3 building blocks are connected to each other. We'll start with asset transaction payment. Let's take a look at the configuration. Let's focus on the type on charged asset transaction, okay, that equals to asset conversion adapter. In that structure, you'll see asset conversion as one of the generic types. So when the runtime receive an extrinsic, we'll use the on-charge asset transaction that will look into the asset conversion to try to withdraw those assets. Then we have the connection between asset transaction payment and asset conversion. In asset conversion, we'll have the next link. We have the type assets that basically is telling you what are the valid assets. You can create the liquidity pools. So they should exist either in local or foreign assets, asset pallet instances. And then you have another type, pool assets. This is pointing to the instance where the liquidity tokens are going to be created. And finally, pool assets, as I said before, the third instance of pallet assets. And we have to focus here on create origin. So only the asset conversion pallet origin can create assets. So any user with a signed origin couldn't create assets, okay? Let's see a couple of examples about how to use the asset conversion. First of all, we need this a pool. So we can create a pool with the asset conversion create pool with an asset pair, asset 1 and asset 2. And then once the pool is created, we should add liquidity to it. As a result of creating a liquidity pool, you'll get a liquidity pool token. The more liquidity you get, the more liquidity tokens you will get. Okay, as I said before, these tokens are created in pool assets. There is not any liquidity incentives in Asset Hub itself, but because they are an asset, they could like reserve transfer to another chain with their own incentive programs. And how to pay fees, okay? How to pay fees with other assets. First of all, the liquidity pool should exist for the asset.pair. Then we need to do a runtime API call to know how many dots we need for our extrinsic. Once we know the dot amount, we use that value for a second API runtime call to the asset conversion. That will tell you what's the swap rate for the asset you want to pay fees with. And finally, use that total amount of assets and include it in the sign extension of your extrinsic. And that's it. I will pass it to Emiliano.
Hey there. Thank you, Nacho, for that amazing introduction. Super, yeah, excited about this whole asset conversion topic. Let's jump before that into a maybe previous use case, which is the case of getting some foreign assets into the asset hub from the perspective of a parachain, but also taking the chance to review relevant parameters on the configuration from the parachain side and trying to understand why is this program like so. So to start with, I will do an initial setup. I have running a ZombieNet network, yeah, that we can check here where it got fired on the Trappist repo, which is the parachain that I'm going to use as reference and where I will be working from. We have a quick setup of the ZombieNet in which we can see that we have a relay, an asset hub, which used to be a statement, a Trappist local, and a Stout local. Yes, basically their IDs are 3000, 1836, and 1000 for the asset hub. Cool. So once we have this test network, local test network running, thanks to ZombieNet, I will jump with Polkadot.js into Trappist local, and then we'll start doing a little bit of the setup that is needed for for this use case. To start with, what I will do is I will try to keep it as simple as possible, get into the creation of an asset. Again, this is just from pallet assets on Trappist. This is something that basically parachains should implement. And what I will do is, of course, this ideally would be the governance address, but let's go with a simple approach. I will create Rococo. This is the testnet that I am emulating. And yeah, with this, I will just use not paying way too much attention to these details because this will depend, of course, on each use case. But I will just create an asset. And then what I will do is I will map it out to a multi-location. Why is this? Because I want to teleport in some rock, or in this case, relay chain tokens, because Asset Hub doesn't have a token of its own. It relies on the relay chain token. And I want to get some assets from Asset Hub into my parachain for being able to pay for fees in that asset on Asset Hub when I want to buy some execution of XCM in order to register my foreign assets. So once I have done the creation of these assets, I will jump into sudo, and this could be done in other ways, but in Trappist we have an interesting system that is registry asset registry, which is a really simple approach on mapping you integers into multi-locations. And as you can recall, I have created an asset with the asset ID 1, and I will map it out to the multi-location of the relay chain token, which is one here. It's one level up, takes me to the relay, and since it's here, basically this is rock, or could be dot, or kusama, KSM. So after this is done, I will register this. And to move forward, what I will do is actually send, right, those rocks from Asset Hub. Yeah, I have an account that has some funds in there. I will send it into my parachain, which is in this case Trappist. Cool. So this is the call that I have already prepared, which is basically a reserve transfer asset in which we are going to send from Ferdi. It could be any account, just it needs to have some funds. I know that here it's Kusama. It's a little bit of difference because of which runtimes we're running, but again, not relevant in this kind of local test environments. The destination is the parachain of Trappist, is the direction of Trappist. The beneficiary is any account inside Trappist from the perspective of Trappist. And the asset that I'm going to reserve as a transfer is going to be one here, which is Rock or KSM. In this case, it's again we can just refer to it as the relay token. So I will submit this, and before moving forward, there is an interesting detail here at the Trappist repo. That is, we are going to do a reserve asset transfer, right? And for this, there are many instructions inside of it. This is not, we are not, focusing especially on the case of XCM itself. So I won't go too deep into this, but we can check that basically we have this combination of, again, not getting into my detail at level of code. This is pallet XCM, but it's interesting to understand that when we are doing this call from pallet XCM, this reserve asset transfer, we are actually asking or executing this kind of stuff. And basically we can see, not exactly here, but it's the same order, that we are going to ask in the destination that they basically get minting derivatives. This is what this instruction does, of the asset that has been sent and moved into its sovereign account, and then by execution with it. This is the only part that I want to make some focus in there, because it's our parachain must be able to buy execution with the reserve asset deposited. And how do we teach our parachain to do so is through the XCM execution executor config, and we have the traders. And if we go to the traders, we are in Trappist. We have in this case a ROC per second, which is fixed rate of fungible. Again, this is a test environment, and we are not using any particular conversion rate. Asset conversion and asset rate will bring this into the table, but at this point, it's just being arbitrary. And as you can see, the ROC per second, the multi-location is 1. No, it's going to be 1 here. Sorry. If we jump into this ROC per second treat, I will look for it. It's basically the multi-location of the relay token. Yeah, I just lost it, and it's not helping the analyzer. But again, I just don't want to spend too much time on this. Basically, what is relevant to understand is that we need to set up a way, which is a trader, for our XCM executor to understand how to pay with some asset. And in this case, is with ROC per second, we are telling him like, okay, this is how much you will pay, or how you pay for execution with ROC per second has the 1 here multi-location inside it as asset ID. And yes, moving a little bit forward and getting back into Polkadot.js, we can see that the execution, we have some assets that has been issued. This is due to the reserve asset transfer that we received. Cool. So not to mess the balances of our sovereign account, let's do a quick recall on how this reserve asset transfer works. Basically, on the reserve chain, which in this case is the asset hub. Basically, you move the asset into the sovereign account, which is an account controlled by this parachain, and then you provide the parachain the right to mint the derivative on their parachain as kind of a proof or receipt that they own this on their sovereign account. However, now we are going to register foreign assets from this parachain. And to do so, we need some assets for the deposits, both for the creation of the foreign asset and both for the asset metadata of the foreign asset. So not to touch the reserve funds that were deposited in that sovereign account due to the reserve asset transfer, what we're going to do is add some extra funds into that sovereign account, which we are going to do with a simple balances transfer. Yes, we are sending some ROCs from Ferdi, again, could be anyone with some funds on it, to the address of the parachain. Sorry, the sovereign account of the parachain. In this case, it's the address of the sibling 1836, which is 1836, which is the sovereign account of Trappist itself. So one interesting, or again, I'm going to be progressing kind of slow due to the amount of detail that I want to cover, especially into the setup for this to actually being able to happen. So an interesting and relevant setup that we do need to do is set the asset hub location as a valid reserve. Again, we are doing a reserve asset transfer to get some rocks from asset hub into Trappist. So to do so, we need to set up two things. And as a quick recap, a trader to teach, which we have here, a trader to teach our executor how to pay with the incoming assets, and a reserves, because here in this parameter, which is reserve, we need to allow the reserve asset transfer from this location, which is asset hub. This is the two main setups that we need to have to actually make this previous reserve asset transfer happen. And now, what is my current status? I have done a reserve asset transfer of rock into an account in Trappist, so that account can buy execution in rock in asset hub when teleporting in some hop, which is the native asset of Trappist. And we have also added some little bit of funds into the sovereign account of Trappist from in asset hub in order to pay for the deposits of the creation of a foreign assets and the set of the metadata. And I hope this makes sense to you. Now, since we have already kind of everything set up in what assets for paying fees relates to, we can start with the process of the setup of the foreign assets themselves. To do so, from Trappist, we are going to do send call, which is going to ask for execution of a pallet in the destination. In this case, we are going to send as destination the asset hub. This is going to go through sudo. Why we are going to use sudo for this? Because when you use sudo, you impersonate the sovereign account in the destination chain. And again, the sovereign account is the one that we have funded for the creation of this foreign asset. And yeah, what makes more sense to be the owner and creator of this native asset on this on asset hub. So what is the logic that we need to add as a message into the send instruction, which is basically to the executor in destination, what it needs to do? It's withdraw assets. Again, since we are calling it from sudo, the withdraw asset will go against directly the funds of the sovereign account of Trappist on asset hub. And this is the asset that we are asking this account to retrieve, which are rocks, or again, relay chain tokens. Then we will ask to buy execution with them. And then we will ask the executor to execute a call or extrinsic, of a pallet in the destination chain. The origin is going to be XCM, and the call that we will ask to be executed, we can check it on Asset Hub, which has been generated on Asset Hub. Again, we are asking from Trappist to Asset Hub, please do execute this pallet extrinsic on your system. That is why the call is originated on Asset Hub. And what is the call? Is foreign asset, create, and then we have this setup. What is the setup? The ID of the foreign asset that we want to create, as Nacho explained, it's a multi-location. And out of convention, the multi-location of a native asset is the address of the parachain itself. So from the perspective of Trappist, the native asset hop, it's 0 here. And from the perspective of asset hub, the native asset of or any sibling chain, the native asset of Trappist is it's Trappist multi-location, which is 1x1 parachain 1836. Who is going to be the admin of this asset? Well, basically, it makes sense it to be the sovereign account, and this is the minimum balance, which is going to be then with the metadata to be set to have 12 decimals. So moving forward with the XCM message that we are creating on Trappist, we have already asked for, okay, please withdraw funds by the execution for you to actually do what I asked you to do, and then execute this extrinsic. Then please refund me with whatever is left from this withdraw that you have done and this execution by, and deposit it back to the sovereign account, which is exactly that. And how do we set up this? Yes, it's basically the account from the perspective of the destination. So it's 0x1 account ID, and this is the address of the sovereign account of Trappist. Cool. Now I will send this from, whoops, I was about to do a little mistake, which is, since we're calling with sudo, the account that needs to call is Alice, in the case of Trappist, being the sudo role. Now we fire. And yeah, while it's loading, I think there's something cool that we can show too, which is on Trappist, for example. This is ZombieNet. This is a cool trick that I think that is useful, is that you can, for example, on the ZombieNet log, when you create a test network, you have these links, and what I do is I press command, click in there, and yeah, let's move this here. And what you can do is to access the log of the collator that you are connecting to. And in this case, I connected myself into the log of Trappist. And we could search for, if, I don't know if I fired it yet already or not, but we could then start, yeah, look, or picking under the hood of the calls that are happening. Now I can see that basically the XMP queue has successfully executed, sorry for that, and that the foreign assets have been created. Which are the foreign assets? This is again on Asset Hub. This is the asset that has been created. We can check on chain, but I will try to move a little forward to try to cover the whole ground, and we can get back into it a little afterwards. So once we have created the asset, what we can do is we can set the metadata. And how are we going to do so? Well, exactly the same logic. I will do this send call. And in this case, the origin is going to be the sovereign account, because the asset is already created. So it's its owner, basically, that is asking for, yeah, the foreign asset pallet on Asset Hub to set the metadata, and the metadata that we're going to set up is this one. Okay, cool. In this case, we are using this ID to identify the asset. Again, it's now, from now on, since it's created as a foreign asset on Asset Hub, we refer to it with this, and then we, yeah, just do whatever we need to do with it. Same logic, reference plus, deposit, and fire away. Let's see if we can catch this log now on the Trappist collator. Let me check if I'm having the execution done. Otherwise, I can plug into the other collator. Yeah, I don't know what this one is not firing away the logs that are interesting. I could jump into the other collator now to check on these logs. However, on the meantime, this is collator 1, this is collator 2. Again, I like to take this time for this because I think that this is particularly interesting, right? Okay, start collator 1. This is, you can see the whole setup of our network being, yeah, happening. And let me jump into a log of, in this case, these are, now we see the logs. Cool. Won't go all up there, but interesting to see also this one. And we can check on the other, maybe I think it's cool to check on the Stout, Trappist, and the statement, which is Asset Hub. This is, again, this is not mandatory. This is, again, since it's a deep dive, I think it's really nice to deep dive into the processes and understanding. For example, here, we can see the whole trace of the, of the message that we have received. A lot of text and maybe a little bit hard to see, but we can see that we have received a message. Here, for example, we can see that we have been asked to execute in credit some XCM. Again, this is the Asset Hub, which used to be called Steinmine log. So we are asked to execute. Then our barriers, we can take a little peek in there too. It's checking which condition it's able to pass, and it says like, okay, allow top level paid execution makes sense for me because this sibling chain is trying to pay execution. And how is it going to pay? With withdraw asset. Again, we can see that the message that we created on Trappist and has been set has its consequences on asset have, which is like, okay, I am being asked to withdraw assets. Which asset? It's going to be basically in this case the relay chain token. And I know how to buy execution with that. I am being asked to buy execution, and then since it knows how to do it, it moves forward and gets into the transact, and it's like, okay, I now I understand what I need to do. Here, basically, it's with execution of, or the request of execution into the foreign asset pallet. Then I receive this refund surplus, and I do execute the deposit asset, which is, okay, I will, to the beneficiary, which is in this case the sovereign account of Trappist, I will deposit every token that I have left on my register. Okay, I really wanted to show especially this part because I think it's super useful to start digging into what happens like step by step once I fire away an instruction through Polkadot.js or whatsoever, and a nice strip down of what happened in there. And I see basically step by step. And if something's failing, I can get into there and review. Cool. Let's see. We're cool. We're cool. Super nice. Checking into the events emitted, we see that the metadata set that basically I previously sent, it's okay and it's working as expected. How we can also check this, we can go into the state of the chain and we can get into the foreign asset palette, and we can check not account yet because it doesn't make too much sense because there are no accounts with funds. But what I can do is just take out the options and query any asset that has been created on the foreign asset, and now we see that it brings back, okay, this asset exists, this is the asset ID, which is the multi-location, and the parameters, and this address is the sovereign account address of Trappist. Again, this was done by decision, right? I mean, this is not done automatically. I choose the sovereign account to be the owner and the role and the relevant roles for this asset. Another thing that we could check on chain is like, okay, bring me either all the metadata that are set, or I can just look at this to start getting familiarized with the concept of looking for a foreign asset based on its multi-location. I can say like, hey, I want to check if there is metadata for this asset, and pound, there it is. In case I would say like, I don't know, I want to check metadata for this other foreign asset. No. Okay, cool. So moving forward, we have a small recap. We have registered and created a derivative of rock in Trappist. We have sent some rock as derivatives into Trappist. We have funded the sovereign account of Trappist in Asset Hub. We have sent an XCM message from Trappist to create the foreign asset, which is going to be HOP, into Asset Hub. And then we registered that sovereign asset, set the metadata for that foreign asset. Okay, moving forward, and I will spend a little bit more time into the next call and operation. It's basically getting some hops as foreign assets into Asset Hub. How are we going to do so? Well, what we're going to do is going to use a withdraw and teleport function. This is super useful because, as Nacho mentioned, your asset conversion is there. It's coming. So it's interesting to have the use case that he showed us, but was basically, I hope that you recall and you can scroll back. It's basically the creation of a pool between DOT, ROC, KSM, relay token, and In this case, he used 0x2 pallet instance and a general index, which is basically a trusted. It's an asset. It's getting into the pallet asset ID and getting into there. This is interesting because he is using the liquidity. He's creating a liquidity pool with an asset that was on the pallet asset of that instance. So you need to have the asset in there. And this is an interesting use case to get those hubs, in this case, to be there so you could use them to create a liquidity pool. For this purpose, what we're going to do is going to use the withdraw and teleport function, which extrinsic, which is an extension of pallet XCM. And basically what it does is send into asset hub, beneficiary is some account, a certain amount of native assets, hops, and the functionality, the cool part about this call is that normally with a regular teleport, you would be needing to pay for execution with an asset that is inside of your teleport. With this extrinsic, what you can do is you can you can pay for execution in destination with another asset. And which asset we're going to pay is basically with ROC or relay chain token. One here, and this is the amount that we're going to send. Of course, since we are going to use that on destination, we need to take that funds on origin to avoid a double spending. So that is why we sent the derivatives of ROC into an account on Trappist. First of all, I will take Bob. And why I'm using Bob? Because I don't want it to be Alice, because Alice is the sudo of Trappist, and it could be seen as, oh, you're using sudo, not the case, even though I'm not using the pallet, doesn't matter. I've just wanted to use any regular account. And since Bob received some ROC, some derivatives of ROC through a reserve asset transfer, basically it will be able to do this and send this amount of hop while paying with this amount of ROC into asset hub. I'm firing away. Firing away right now. Once this has been done, I'm having the foreign assets issued. And then, super cool. I have these funds now on Alice, which has been received. So moving forward with this process, there are some, we can do is teleport this back. And this is the interesting part. Once this is done, and once this setup is done, everything is actually super smooth, simple, and secure. I mean, I could be seen at this point that it's like, oh, it gets a little too complex. Yes, but this is something that once you could use this to create the pool, and then it's fixed and it's set up, and then you get seamless integration. For example, a quick example of that is now that I have the hop in there, I can basically do a simple teleport back into asset hub. Yes, with the destination being that, the beneficiary any account that I want to, and send them back to Trappist. So interesting checks or interesting points to look out on how you are able to receive this teleport or hops back is basically if you get into your configuration, you need to have trusted teleporters. In this case, the trusted teleporter is asset hub, so basically it will accept teleports back. So again, another point to check out when setting up your setup if you want to allow teleports back in. And another relevant topic that I want to highlight is related to the configuration of which assets you are allowing your users to teleport out. It's basically you can do so by this XCM teleport filter. And in Trappist, we set it up to only teleport native. We only want users to be able to, yeah, cool. We only want users to teleport out the native asset, yes, which is basically, again, out of convention 0 here, in order to minimize the possibilities of, yeah, mistakes or whatsoever. If we want to get, again, not to make this extremely intro into XCM, but I think it's interesting where does this XCM teleport filter is checked. It's done on the pallet XCM. If we go to reserve asset transfer, and we can go to the reserve asset to teleport assets here, and we can see that the XCM teleport filter is being checked. Before moving forward, I don't know if I fired this right away, to be honest. No, I didn't. I can just fire it. Boom. How does this whole process look into a wider perspective? Well, basically, you start with your XCM configuration. Then you, as a parachain, then you go and check into, because it's useful, into the XCM configuration of Asset Hub. Then you create your logic around it, and you are able to trace that down. And at some point you might say, like, I don't fully understand what I don't know what is this teleport, or where it's being used, or I don't understand on the executor what this is teleporter is, or why do I need to set this up, and so and so and so. Well, the solution there is pretty much jumping into, now it's the monorepo, but the Polkadot repo folder, and check on. I know that it might look overwhelming to start with, but once you get into the flow, which is kind of something that you start like narrowing down the places that you actually need to check anything. And most of them, since we are interacting from Polkadot.js, is through pallet XCM, which exposes instructions. And again, there are like two landing spots for most of your issues, which are the pallet XCM itself, and it allows you to check, okay, I'm doing a reserve asset transfer or a teleport asset. What does it actually do under the hood? And then you can go into the code, right? And the code itself, yeah, a lot of checks to verify that the versions are correct, and so on, so on, so on, calculating correct weights. But at the end of the day, it's like you get an origin, you get a destination, you get a beneficiary in that destination, and you get some assets to send. Okay, the amount of assets that I want to send, are there too much or too many? Sorry, or are there like an allowed amount? Yes, move forward. Okay, am I allowed to send this out? Yes, move forward. Then this is a re-anchoring, which is changing the perspective of my asset into the destination. Works. And so then I calculate the weight based on the instructions that I'm going to execute. Okay, then this is what I'm going to execute. Okay, then just transfer the asset. I mean, I know I'm not over, and then it's executed. I'm not oversimplifying this because this is not simple by any means, but I'm just saying that there is a logic behind this, and once you start getting into the mood, you are able to follow or mostly follow the relevant steps down. The other spot which is relevant to look at with these kind of situations, because it might happen to you like, I don't know what this message is not passing, or what the barrier, the so famous barrier that will go into there, is not passing. And so it's useful to check the instructions that are actually being executed on the XCM executor, and you can find them on the XCM executor implementation, and you can see that, for example, I don't know, receive teleported asset, or transfer reserve asset, or transact, or what do they do, right? And this is the interesting part, like you see the code that actually gets executed once you receive one of those assets. And just out of yeah, for example, one case that we did have a small issue while building this was that, for example, when you are teleporting, it force you to put a receive teleported asset function. It's like, on what is a receive teleported action? You go into that instruction, and then you see that is basically a mint. I mean, yeah, in the context of, yeah, which is has been destroyed on the origin, and asset data are minted into the holding register. Maybe the naming sometimes gets confusing, but it makes start to make sense in the context of the whole execution. But this, for example, it's a mint, and then you logo like, oh, now I understand that I burn on origin and mint at destination. Again, don't not to make it this fully into XCM, but providing useful tools on how to debug and build as a parachain these kind of use cases. The barriers could be an interesting case to look out to and check to, and the most common one is used as a parachain or as a sibling chain interacted with any other sibling chain, because it makes sense, is that I am allowed to execute on the destination. As always, I pay for execution. So yeah, it's an interesting case to check. For example, we see that these are the instructions that are kind of whitelisted. And if you don't have these instructions as the first instruction of your execution, then I will not accept it, because that means that you won't be able to pay for execution on destination. And then the next relevant instruction must be by execution. Otherwise, this would fail. Again, a lot to take in, but interesting to get a little bit under the hood and get with the flow of how these assets go and move from one place to another. There should be an XCM. Yeah. Now we see here on Trappist, we went from, remember that the last thing that I did in this Polkadot.js interface was from asset hub sending and teleporting back some hops into Trappist. This XMPXQ success was that execution, but it's just a balance transfer at the end of the day, because it's the native asset of hop itself. So it doesn't create any, like, I don't know, foreign asset created or anything like that. It just it's a, since it's in the context of Trappist, it's a native asset. It's a balance transfer, and I think we are almost getting there. But I will just send again some funds from Hope into, sorry, from Trappist into Asset Hub. Once again, I'm going to use Bob, which was the one that received the rocks, and it's able to execute this. Sending again. Beep. And the last step that we're going to do is do a reserve asset transfer from Alice into, from Alice in Asset Hub into another chain. And in this case, we are going to use Stout for that purpose. This is Stout. Again, if we check in Asset Hub before moving forward, for an asset issued into Alice, Alice has more funds into her account. And I think that this is kind of the most relevant use case, but we have some minutes left. So let's use them to one last push into this reserve asset transfer use case, in which we have teleported in some assets from Trappist into Asset Hub. Since we have them in Asset Hub, we can use Asset Hub as a trusted reserve for the ecosystem, which is one of its main purposes. And with that, it can be the only point of contact for you to get your tokens into other chains. So kind of interesting topic and use case. To do so, what we're going to do, we're going to create an asset on Stout, which we are going to call ST Hope, which is the derivative of Hope in Stout, which is another parachain, simple as that. As a decimal this, again, not paying too much attention into this topic. And the asset ID, we can put the asset ID, for example, of Trappist, just to make some coherence in there. And when I say like I'm not paying too much attention, it's like, yes, this one should be the governance or relevant address or whatsoever. But for the sake of the demo, what we just needed is an asset to be there. So once again, on the Stout, what we do also have is an asset registry palette, which will allow us to map out our asset ID into a multi-location. And in this case, the interesting part is that the multi-location basically is going to be this one, because this is the ID, the asset ID of the hop, right? And because remember, we resisted it also in asset hub. So what are we going to do? What are we doing and saying now is like we are setting up Stout to receive hops with this asset ID and map it out into an internal pallet asset, and we'll map out to that integer. These many steps are mostly because we are doing the setup live. Once this is set up, this is something that you only need to do once, and then you forget mostly about it. But again, that is why the deep dives are for, to go into this kind of deep dives step by step. So once this is done, we have the hope ready to be received asset on Stout, which is a third parachain. And what we are going to do is we are going to send, and this is again when it starts to get easier, because now we can just send a regular reserve asset transfer from asset hub, right? Alice was the one that received the hop. She's going to send it into, and before doing that, I want to do one extra step. And basically since she received this, she will be able to reserve asset transfer them, in this case to the Stout parachain, which is the number 3000, and into any account in there. I think this is Bob or Alice, I don't exactly remember. And what are we going to send? We are going to send basically hop and a small amount of rock, which we only need to send once. I think this is the easiest approach to this. We can also send the sovereign account of Stout on asset hub, but basically remember, a reserve asset transfer is putting the funds in the sovereign account of a parachain and allowing derivatives of that amount to be minted on the destination on that parachain. But for the sovereign account to exist, we need a small deposit of relay token account, relay chain tokens deposited there because of the existential deposit. So basically with this, what we are doing is putting a little bit of rock for the first time in there and then sending the reserve asset transfer. And what I want to check is before, and this is the wrap up, I want to go into the foreign assets account. I'm not including any options, and I will just ask, please list me all the assets, all the accounts, that have these assets, this asset, which is Hope. And then we can see that we have Alice here that has this balance. And now we will fire this. And on Stout, ideally, we should be receiving a reserve asset transfer. Since this is live, I might have messed the balances and maybe not have enough balance, but not the case. I have successfully received a reserve asset transfer of Hop into, this is the two relevant events, into Stout. And now I see that if I go to the assets, which is Trappist, I see that there is a balance in there. And I don't know, these are relevant roles. I don't know exactly who received it. We can check on pallet assets, account. Bring me back. There is an account in there that has for this token, this balance, which was what was received. And one interesting case, I think that we can see this, is that if we, yeah, I don't know if this updated, but I wanted to check, not that I wanted, yeah, here, sorry, the basically that there was this execution correctly done from asset hub, and basically that we have sent the, yeah, the tokens out of asset hub into, in this case, stout. Well, I think that this kinds of wraps it up. We have seen, and just to yeah, to round it up, sorry that I went a little bit out of time, is what we did was following all the steps. What we initially did was the creation of an asset that represents rock on Trappist. We sent some of that asset into, from asset hub into Trappist, in order to be able to buy execution in rock in asset hub. We have then founded our sovereign account of Trappist on asset hub, and there we have created the foreign asset, which was hop with the multi-location of Trappist as the asset ID. We have also set the metadata of that asset. After we have done that, we have done a teleport of hop from asset hub, sorry, from Trappist to asset hub, paying with rock, paying with the execution with rock, thanks to withdraw and teleport function. Then we did a teleport back of hop into Trappist from asset hub, from the account that receives the hops from the previous teleport. And then we registered another asset that we were going to use as derivative on stout. And then we did a reserve asset transfer of hop from asset hub into stout, which is a third parachain. And I think that we are there, and that's it. I hope you enjoyed the session. I don't know if we have any questions or anything that we need to address. Otherwise, I think we are good, and I hope this serves as a cool example of how to start getting into this topic. Again, a lot of code related to the setup, and some cool functionalities coming out soon, like the asset conversion and so, which will simplify this process. And once everything is set up, this could be pretty much seamless. Yeah, allow basically asset hub to become kind of the reserve and the single touch point to interact with assets all over ecosystems. And when, like Nacho mentioned it, when also adding bridges into that, the things get starting like really, really, really solid. So yeah, get in there. I don't know if we have any question or any topic.
Yeah, there was a comment. There was a comment, so I wanted to reply. It's about the complexity of it. So I just wanted to explain that this is a deep dive, and from the user perspective, you don't need to build all these complex XCM messages, selecting the multi-location. So from a user perspective, you can use one of the wallets. For example, Nova Wallet is a really nice wallet with a super nice interface. So the only thing you have to care is about this asset from this chain to this other chain, this amount. That's it. So yeah, I just wanted to reply to one of the comments and to clarify this point.
Yeah, cool.
I think there are not more questions. Thank you, Domi.
Yeah, thanks.
Okay, thank you very much, everybody. We see you in the next deep dive. Bye-bye.
Bye-bye.